Throughout human history, astronomers, physicists, and cosmologists from around the world have observed a sea of evidence, which has culminated in a theory that explains the very origins of our universe. This theory, commonly known as the Big Bang Theory, explains not only the beginning of the universe, but everything in it, including Earth itself. The Big Bang Theory is based upon a tremendous amount of astronomical and cosmological data that, when put together, provides strong evidence for an expanding universe. Cosmologists, who can calculate the rate of the expanding universe, then run their cosmological models backward in time, are able to calculate a point in time and space about 13.75 billion years ago, from which the universe began. That point in time and space is known as the Big Bang Singularity, or gravitational singularity, an incomprehensibly small point of impossibly high density, pressure, and temperature, in which time and space themselves lose all meaning. The Big Bang was an instantaneous explosion of all matter from this singularity. It would initially have been a massive primordial cloud of subatomic particles. The temperature during this 1 second would have been 10 to the 32 degrees Kelvin, or 100 quintillion degrees Celsius. The ratio of neutrons to protons as we know it today would have been established within the very first second following the Big Bang. Between approximately 10 seconds and 20 minutes after the Big Bang, some of the protons in this primordial cloud would remain as hydrogen, and countless protons and neutrons would fuse into deuterium, the helium isotopes helium-3 and 4, and lithium-7 in a process called Big Bang nucleosynthesis. These primordial elements would go on to be responsible for the creation of all other elements on the periodic table as we know them today. But what does this all have to do with Earth? How did Earth form from this hot primordial cloud of protons and neutrons? At about 24,000 years after the Big Bang, still 13.75 billion years ago, the universe reached a point at which it had more matter than energy, allowing the universe to cool and slow its expansion. At about 370,000 years after the Big Bang, the universe had cooled to about 2700 degrees Celsius. It is during this period of time, known as the recombination epoch, that electrons begin to combine with protons to form stable atoms. This process results in the emission of photons, known as photon decoupling. At this point in time, 370,000 to 380,000 years after the Big Bang, light photons are able to travel freely through space, and the universe becomes transparent. We can still see the remnant electromagnetic radiation from this period reaching us today, known as cosmic microwave background radiation. At about 100 to 200 million years after the Big Bang, gravity has firmly taken hold of the heterogeneity of the universe, and the first stars begin to form. For more on this and other amazing Earth science topics, stay tuned for another Earth in Depth video. If you enjoyed this video, please consider liking, subscribing, and visiting the links in the description. And if you just can't get enough Earth in Depth, please consider joining our Patreon, where you will get immediate access to our exclusive in-depth videos on all things Earth science. Your support helps us immensely to create more content just like this. Thanks again for watching. We hope to see you again soon.